Good evening, ladies and gentlemen, and thank you for turning out on a cold night. I was expecting the audience to be really tiny tonight because at face value there couldn't be more irony really in lecturing about drought at the moment. We've had rainstorms of almost unprecedented length and intensity in the north of England and in Scotland in the last fortnight, 3 weeks. And I think we're very fortunate that the loss of life has been so limited. I mean, I say fortunate, but actually this aspect of the situation isn't an accident. It's partly the result of changes in the arrangements for managing floods that have taken place since the massive £3 billion event in 2007 in Midland, England, and a series of inundations afterwards, as many of you will recall, in 2012, 2013 and so on. And we produced reports. In fact, I participated in the production of some of them myself, and there was political action to change the arrangements and to alter how we respond to those kind of calamities. So whether that action was sufficient or sufficiently well funded is a theme to which I might return later this evening, but certainly what was done about the emergency services has actually paid dividends in terms of saving lives. So now, in my own opinion, what we have to do now is to get rid of the use of sandbags, and I'm making that my personal priority for the next 12 months or so. We need to use better form of protection and more action on climate change, but that's a story for another time, I think. I will just show you, though, a slide that a colleague of mine sent to me earlier this week, which I thought was absolutely wonderful. He said, he sent me this image from the mainstream press, which suggests what happens when you mess about with nature by naming storms. Anyway, that's flooding, and some of you, I think, may remember that I spoke about flooding just before Christmas. I hope that wasn't what followed, wasn't the result, and I'm not planning that what I talk about today is going to follow next summer either. But floods and droughts, of course, are intrinsically linked. And the history, let's get rid of that. The history of our planet shows that shifts in climate are periodic. In the UK and in other places, we've previously experienced historic periods when flooding was a frequent occurrence, followed by decades of droughty years in a very complex cycle. And today, particularly after the outcome of the Paris talks a week or two ago, we should be thinking too about the implications of climate change. At the moment, national attentions, obviously in the UK, has been on the link between climate change and flooding, but there is an equivalent link with drought, and I'll come back to that later on. Now, we can think, I want to show you something, a rather beautiful piece of film in a second, but we can think of the Earth's atmosphere as being like a rather unstable set of different sized packages of air, and they're being blasted around this rotating sphere at distinctive and different heights, and they're driven by radiation coming from the sun and then re-radiated heat coming from the ground, from the oceans, and increasingly from our cities. And what we see is that these bubbles of air get twisted and tossed and torn around in rather unpredictable ways by faster moving jets of air that fluctuate, and the patterns sometimes push northwards or southwards, so it's a very fluctuating situation. I want to show you a little extract of a film shot in Arizona by someone called Davo Leninga, just so you get your mind around the complexity of what we're trying to describe and forecast. Okay, now what you saw there was something amazingly complicated, and I want you to imagine that scaled up, because that's the kind of thing that we're trying to forecast when we look at the prediction and forecasting of drought. What we see on the ground, we put this up, on the ground we see periods of instability and rainfall when these packages, these bubbles of air cool and release their water vapour, followed by periods of calm and warmth and dryness when they don't, in a way that's very, very difficult to describe, let alone to forecast. So when we come to things like drought, forecasting and understanding the origins of a regional drought is very complex, even solely in terms of the Earth's physical parameters. We do know that droughts are associated with planetary scale perturbations, we call them, in circulations in the atmosphere and the oceans. So something called, if you want to drop it into your pub conversation, the North Atlantic Oscillation, for example, which is partly shown in some of these complicated diagrams that I've got on the screen at the moment. It's the jet stream, if you like, if you wanted to simplify it. It's implicated in European droughts. And you can see there on the right-hand side of the screen something called North Atlantic Oscillation positive situation. If you look at the black arrow that I've written the UK on there, you can see where the UK is, and you can see that in the second of those diagrams, the arrows are thicker. The UK is experiencing sets of very strong westerlies, and it's tending to be rather dry. And that's actually the situation that we're in at the moment, more or less. On the left-hand side of the screen, we've got a negative position of the North Atlantic Oscillation and different kinds of conditions. Now, I don't propose to try and describe what's going on in these diagrams. The way we have of understanding this is very complex indeed. The Met Office in Britain are actually very good at developing these models. But we do know that in general terms, we can make comments on what's likely to be causing periods of similar weather, which is of course what we have in a drought. Now, the problem comes because the different indicators that we use tend to give us different outcomes. And I put up here the forecasts that were being made about this winter, the winter we're in at the moment, which has, until tonight at least, has been remarkably warm and actually well, certainly warm. But if you look at the different kinds of models that were being used to predict back in the autumn what this winter would have been like, you can see that some of them suggested it was going to be a milder than average winter. Some of them suggested it was going to be possibly a colder winter. It's a confusing prospect. We don't yet know how to make these forecasts, but actually if you look at the last one, number 6 on the list there, cold winters and indeed warm winters and droughts and floods tend to come in clusters. So actually if you were having a discussion with your bookie, you might well say, well, next winter's going to be the same as this winter, and you'd be better than evens on that. So perhaps might be worth putting some money on it. But that's not always the case, of course. Now, drought isn't only a meteorological phenomenon, of course. That's a relative concept, less rain than usual. But in some definitions, it has a societal origin as well as societal consequences. So drought is partly driven by our expectations, the way society behaves, the way it uses water and makes demands on water, as well as drought having consequences for people and society. So we've got 3 different definitions of drought up here. None of them is either completely right or completely wrong. We've got what is usually called a meteorological drought. We've got something called an agricultural drought, where the effect is on farmers, and it's particularly associated with very dry soils. And we've got a water supply drought, when people are starting to become concerned about whether they have enough water. It might not be rainfall in their own area, of course. If you live in Midland England, like I do, you'd be rather concerned about the rainfall in central Wales, because that's where our water supply comes from, and that's, again, something I'll return to a bit later on. So we've got these different definitions of drought. Perhaps water supply droughts are the ones that should concern us the most, because we are all familiar with the major humanitarian catastrophes that can follow exceptionally large periods, long periods of dry weather, even where typical rainfall is anyway low. If you keep your eyes on the press at the moment, in South Africa at the moment, in the Free State in South Africa, less than 150 miles from Johannesburg, people today will have been queuing for borehole water for hours in temperatures in excess of 40 degrees, having travelled by taxi in some cases with a couple of buckets to collect the water because there is such a local shortage. Their crops, their livestock are already dead, and that is in fact the situation across quite a wide area of Central and Southern Africa at the moment. The World Food Programme is predicting that the environmental drought effects of El Niño, that upwelling of warm water in the Pacific that we saw mentioned in the list of things that may create drought, is expected to last until at least 2017, so more than another 12 months. And it's anticipated that the food security of about 29 million people is likely to be compromised. We get dryness and we get heat together, of course, with positive feedback between them. We lose the evaporation from the soil, we lose the shade from the vegetation, and the air temperature is consequently raised closer to the ground in a cycle, an escalating cycle, that's only broken by a sudden change in the things that are driving it. So it ratchets upwards. The drought gets more and more intense, usually, until suddenly it ends. It collapses. Drought isn't, of course, restricted to the developing world. Those of you who know Australia or who have relatives out there, many of us, I'm sure, will perhaps be aware that parts of Australia are experiencing unusually dry weather and something which we might define rather better as water scarcity, though people, of course, are not yet reduced to collecting their water in buckets, and their personal consumption remains, well, certainly in California, which I'll talk about in a second, probably their personal consumption is 100 times what it might be in South Africa. Rainfall in Australia, eastern Australia, has been low for the last 8 months or so. So this area over here, rainfall has been low for about 8 months or so, for quite large areas. But if we go to a 3-year period, look at it instead of over 8 months, over 3 years, the area affected by these very low rainfall less than 10% of what it would be normally, is much larger. 17 years, actually, the rainfall in this area, of eastern Australia. We've had a 17-year drought, more or less. Some floods intervening, if you can remember as well. But, of course, it's stimulated bushfires, it's damaged property, and it's killed people as well. So what I wanted to illustrate with these two maps in particular is that the definition of drought depends on how long a period you're thinking about, as well as how little rain the area experiences. This is, in Australia, of course, a very widespread and intense drought over a multi-year period. It takes huge amounts of data, of course, to produce these maps. We talk about them as being data hungry. In South Africa, that data is simply not available. It is available in California, And again, here we've got a long-standing meteorological drought in California. The yellow and brown areas on the map indicate where rainfall has been abnormally low. And then if you look carefully at the map, you can see there are some letters here, S and L, and those are indicating an indicator of the length of the drought, short or long. So in some parts of California, down here for example, we've got long periods of drought. Where it's very, very intense, it's been very intense over a shorter period. So we've got various complexities just in defining a drought. It's the length of time, it's the amount of rain relatively as well. And then, of course, we've got the impact of what humans are doing with the water. In California, as many of you know, the water is piped and pumped very long distances from the north of the state down to the much drier south. And it's being brought down largely for agricultural purposes, but also for the cities in the south. I don't know if any of you are aware how much water it takes to produce an almond. Would anybody like to speculate? No? This is an area of almonds in California. Well, it's about a single almond takes about 5 litres of water to produce. And profit is to be made even in the middle of a drought in California by growing almonds. Now, in fact, almonds have been let off the hook recently because it's been revealed now that other fruit trees and nut trees are equally thirsty. Peaches, I think, being a good example. So they're no longer the, if you like, the drought scapegoat. But it begs the question about longer-term sustainability of agricultural systems like that. Despite the extreme rainfall deficiency, and this is, let us be in no doubt, this is a meteorological drought as well as a period of water scarcity, most Californians still say the drought has not had very much effect on their day-to-day lives. An average resident in California, in Southern California, uses, and I need to check this figure because I can never quite believe it, something in excess of 2,500 litres of water a day. That's just in the house. In the UK, our figure is about 120. Now, they're using it for washing cars, for watering lawns, for filling swimming and emptying, presumably, swimming pools and so on. They are looking at some water recycling, but what it's highlighting here is the fact that drought is partly defined by the way we use it, by cultural norms, as well as by areal extent, duration and intensity of rainfall. The major difference, of course, between the developed world and the developing world is that in the developed world, fewer people die, and in our developed world, we use money and technology to overcome at least some of the consequences. Drought can, of course, drive people to pretty desperate actions in the face of disruption. It disrupts their normal economic functions and worse, and its implications ripple out, if you like, across the economy, from agriculture to more insidious effects on things like power generation and people's available time and ability to work. There's been a great deal of debate in the media recently about water security and its implications for the Syrian War, for example. Everyone from President Obama to Prince Charles through to Charlotte Church has been talking about it, and I do have a little extract here of Charlotte Church talking. This is the pictures that we see from Syria. There is a drought going on. The brown areas on the map at the top there are the areas where drought is most extreme meteorologically. Let's just hear what a little bit about what Charlotte Church was saying.
Another interesting thing with Syria, actually, which the people that I've spoken to, lots of people don't seem to know about this, but there is evidence to suggest that climate change was a big factor in how the Syrian conflict came about, because from 2006 to 2011, they experienced one of the worst droughts in its history, which of course meant that there was water shortages and crops weren't growing. So there's a mass migration from rural areas of Syria into the urban centres, which put more strain, and there was resources were scarce, etc., which apparently did contribute to the conflict there today. And so, when we're looking at, no issue is an island, when we're trying to look at all of the different factors in this. So I think that we also need to look at, what we're doing to the planet and how that might actually cause more conflict in the world.
Okay, now I don't think Charlotte Church, and certainly the researchers that looked at this, are actually saying that drought causes the war in Syria, but drought certainly drove up food prices, it's made children ill, it's killed livestock, it has forced some people, villagers mainly, in Syria, from Syria's villages into overcrowded cities that were already overcrowded because they were dealing with Iraqi war immigrants. So drought is not the only catalyser of violence, but there must be, unemployment, weak government and so on playing a role there. But it does show that the potential human implications of a severe drought are indeed very serious indeed. And we'll come back to this theme right at the end of my talk, because I think it does indicate something of the significance of the activities that people will do in trying to cope with the consequences of drought. Now, a bit closer to home, I want to take a bit more detailed look at the anatomy of a drought in Andalusia in southern Spain in the 1990s. So this is the area down here. I don't know if people know it from holidays. I certainly do, as well as it being a research area of mine. We're down in the bottom of Spain here, in the area around Malaga, the Costa del Sol. And I'm going there actually in a couple of weeks. I'm looking forward to it immensely. But it's an area where in the hills in the winter you see snow-covered mountains, the Sierra Nevada, and then lower down you've got these terraced slopes with vineyards and olives and citrus plantations, and then along the coast to the far south we've got this mass of beaches and so on. I should just tell you the story that I took students on a field trip here, and one year, I used to take them regularly, and one year a student said to me, "Why did they call these mountains after the Sierra Nevada in America?" And I was thinking, need a history course there. But anyway, this is a bit of hydrological data. So I'm wanting to look at a river here, which is called the Guadalhorce River. It rises up here in the hills, some reservoirs in the middle here, comes down here and out onto the coast by Malaga. Just indicate, how many of you have been to this area? Any of you been to the coast? Yes, well, you see, half of you at least. Good. Well, if we look at this area, this is a rainfall map, and I've put for comparison up there, I've put a rainfall map of the UK, and actually the area is not so different from Eastern England in terms of the basic amounts of rainfall it receives. This part of Spain typically gets about 500 millimetres a year, but the variability from year to year is high. Southeastern parts of England normally receive a little bit more, about 650 millimetres as opposed to 500, and it's a bit more reliable. And of course it's hotter in Spain, but England has more people per square kilometre, so there's a trade-off here. Not so different overall, perhaps. What we do note, though, is that the sharp annual cycle of water availability in Andalusia and the regional disparities have had to be managed for many years, and I'm sure some of you, if you've been to this area, will have seen the Alhambra on the right-hand side there. The water management of the Arabic civilization that was there until the time of Christopher Columbus, and before them the Romans, left its mark in the engineering, in the water engineering, in these reservoirs and aqueducts and so on, that are really stunningly beautiful in some cases. Many of them still function. And alongside those, we've got modern channels, much less scenic, and modern reservoirs as well. And we've got boreholes going down into the limestone, which would not have been able to have been drilled in historic times. Now, I showed you those reservoirs in the centre of the Guadalhorce basin, 2 out of 3 of those reservoirs, there was a kind of set of sort of fingers, a 3 reservoirs sort of coming together at one point. 2 out of 3 of those reservoirs were built in the 1970s, and the other was mainly, it was built in the 1920s, really as a sop to quell political dissent amongst the very impoverished local people. So it was an investment by Madrid to kind of keep the locals happy, or happier. So I want to just look at these reservoirs. I have a series of photographs here that showed you what happened in the mid-1990s. And you can see here a picture in December 1993. This is one of the reservoirs, and you can see the water level is quite low. Rainfall was low, and the river network started shrinking away. So by April 1995, it was looking like that, and by December 1995, it was looking like that. The fish were dead. It was actually pretty disgusting. The smell was horrendous. And the water that was available was very, very salty. There's a lot of evaporation, salts drawn out of the soil, and any water that was around was virtually unusable. So you can see here that the large areas were essentially barren. In December 1995, so the last picture there was of the reservoirs was December 1995, about 2 or 3 days after I took these photographs, all hell broke loose. The drought ended incredibly suddenly, with flooding, with landsliding, with rivers being ripped up and settlements being ripped up, and an enormous plume of sediment going out well into the Mediterranean. Now, this is a graph. It just goes through there are 3 parts to the graph which ought to be put together in a strip. So we're going along the top, and then along the next line, and then along the next line. And what you're looking at here is the little histograms of the rainfall, the monthly rainfall year by year. So here we've got 1971, no reservoirs. As we go along, it's raining, and the reservoir level is kept low by the engineers because they want to let the dams harden, solidify, all the rest of it, bed in. And then you get quite a high rainfall here, and the level of water goes up, and we have a period of time where it's high. Then it's dropped down again. They had some flooding, so they decided to keep the reservoirs empty to try and hold floodwaters back. But the bit I want you to look at particularly is this bit down here, because from 1992 to 1995, you can see a catastrophe developing. The water level, the rainfall was relatively low. The water level dropped and dropped and dropped and dropped until, if you look at the figure here on the right-hand side, it's almost literally at 0. Now, if you'd have been the water manager in that area, your head would have been on the block. They were about 2 weeks away from a complete disaster. So what did they do about it? What were the human consequences? Well, of course, they used water, they put it into that network of pipes, kept on feeding it down. People have to drink something. But as the drought ratchets up, as it gets more and more extreme, people were asked, rather nicely to start off with, if they didn't mind using a bit less water domestically. It didn't have much effect, actually, tiny reduction in use. And then they turned off the taps to the farmers, which, of course, started to create social unease. And, of course, after a period of time, we're talking 2.5 years, 3 years here, crops, including trees, started to die. And so the farmers got pretty angry, particularly because golf courses and hotels and people like you and I who were staying in them were simply not aware of what was going on. There weren't any restrictions on hotels. They didn't want the signs of a developing disturbance to upset the visitors, I suppose you might say. As time went on, no prospect of an end. they started doing other things as well. They had an emergency groundwater drilling program. Actually, I don't want to be quoted on this, and I shouldn't be saying it on camera, probably, but it was bonkers. I mean, they drilled on a kind of grid network, including in areas where there was no prospect of finding any water. It was called the Colander Project, because there were so many holes being made. But the civic dignitaries were seen to be doing something. That's the point. They were drilling, they were looking for water. They started to impose restrictions on houses. In fact, they started to cut houses off for up to 16 hours a day. But even that didn't do much, because people built large tanks in the roofs of their houses. So when the water was on, they filled the tank and carried on as normal. They started building a pipeline along the coast to try and annex, if you like, water from a little bit further along. That, as you might imagine, wasn't very popular with the people whose water, who thought it was their water, and the farmers in the adjacent areas, and in fact that was stopped by the courts. It got very nasty indeed. There was a shooting. There was a lot of fighting. Somebody, alleged to be groups of farmers, started throwing sheep carcasses into the public supply because the farmers were angry that the cities were still receiving water. And the water quality deteriorated dramatically. I think, yeah, I have a picture here, an image here of what happened. This is time going on here, and this is salt. This is sodium chloride, the blue here. Sodium chloride levels going up and up and up and up, and then here's the flood, and it suddenly ends. And around here, it was like, if you drank the tap water, it's like drinking seawater. I mean, it was really horrific. Okay, so we know, if we analyse this as a meteorological drought, it was fairly extreme. Now, I'm not going to go into the mathematics of this, you'll be relieved to know, but this is how much rain there is in a year. And here we've got an estimate of how frequently we might expect an event of that sort to occur. And this period, the year at the end here is 1994-95. Rainfall was only around 200 millimetres. And if you look at the kind of trend here, you can see, if you look down here, it's probably has an indicated recurrence interval of maybe 30, 40, 50 years, something like that. But the problem is we don't have very long records in this area. They've only really been recording rainfall accurately since those reservoirs were built. And if we look a bit longer, I managed to assemble a much longer data set. They're very good records. We British are very good at this, I should say. The best records are from Gibraltar. And you can see here that if you go back to the 1850s, there's some other droughts here in the 1860s and 70s, very long period of drought, and here's another one here. Now our drought would look something, it's off the end of the diagram here, but our drought that we've just been talking about would look something like this one. So actually, it may not be that unusual. There's 2, 3 of them in that period. Now, in Spain, what they're going to do about this, or what they are doing about it, I'll skip over this. There are some problems with the data, but what they're going to do, what they say they're going to do, is gradually start moving water around the country. We talked about the pipeline a minute or two ago being built along here from Murcia. It doesn't exist yet, but that's allegedly what they're going to do. And if they don't do that, they are going to run out of water. The groundwater in that area during the course of that drought dropped. The groundwater level dropped by 80 metres, 80 metres. You know, that's a hell of a problem if you're dependent on a pump on the end of a hose. You know, how many people do you think have 80 metres of hose pipe? Now, if you turn to the UK, to England, you might say, well, we are a much more resilient economy. Are we, though? That's what I want to ask you. How many of us remember some of these droughts? Our memories are going to be a bit drowned out, aren't they, at the moment? I'm guessing at least some of us in the audience would remember the 1975-76 drought. Yeah, some nodding, yeah. We might remember things more recently, although we have a very partial memory. The 1995-96 event in the north of England actually created huge economic disruption, though it attracted a lot less attention in the London-based media. In 2010 and 2012, very recently, we've probably almost forgotten that there was a drought going on then as well. We are actually at the moment, despite the flooding we've also had, we have been experiencing a decade of drought, a droughty phase. If we go way back into English history, we find catastrophic droughts or evidence of catastrophic droughts in historic records. If you look at manorial records for the 14th century, for example, you find massive death toll. I was testing this on Valerie earlier and I said, I'm sure it was 1 million people, and she said it can't be, there weren't 1 million people around then. The death toll was extremely high, and it's recorded in records. People got various kinds of illnesses. We look at it and it looks like it might be malaria when we read the descriptions. They certainly got diarrhea of various kinds, the crops died, there was widespread starvation and a huge death toll. Now, I don't suppose any of us, I'm looking around the audience, any of us can remember these ones at the bottom here. Don't think anybody would remember that one, but there are plenty of others. Now, let's just have a quick look at the 1976 drought. It looks like looking at another country, doesn't it? Another age. But there's what was going on in the media, what was going on the beaches. I love this man. Looks like something out of Monty Python, I think. I like the camels here. They were from Longleat. I think they were just being given a walk, but it made a nice image. Some of the rivers, the Kennet, there's completely dry. Now, again, we've got this same ratcheting effect. Here's the rainfall from 1974, here's 1976. The red years are years with deficient rainfall, low rainfall, and the blue years are a bit higher than average. And we see, if we look at this period here, we had a dry winter in 75, we had an intensely hot and dry summer in 1976. I don't know how many of us remember what we were doing in that summer. I was a postgraduate student, and there was somebody that was in the same department as me, was trying to do some research on sediment flow in rivers. I should say he never finished, because I think the whole time he was there he had about 3 events, and one of them was then when all his equipment was washed away. Because if you remember it, it ended again catastrophically with flooding. How did we cope? You'll have seen cartoons like this. You know, people were advised to bath with a friend. Do you remember that as a slogan? Ice cubes disappeared from pubs. Well, we weren't actually very good at that anyway in 1976. And British Rail, do you remember that? They stopped washing the trains. But then, did they anyway? More significantly, though, some very important policy decisions were taken by central government, who were the responsible authorities at the time. Now, a question I want to pose you then is, was this a failure of the management system? Because what happened, some of what happened under Margaret Thatcher's leadership was quite interesting. Industry was protected at this time, whereas householders, domestic consumers, had their supplies cut off and they were put onto standpipes. I don't know if any of you remember this, I do. I was in Devon at the time. It was very, very unpopular, and it obviously particularly affected women, as is apparent from the picture here. If you asked me whether that would have happened in Chelsea, as opposed to Colompton, where I think this photograph was, I'd have to say that Devon is a very long way from London, just like Cumbria, underwater today, is equally remote. Second policy decision, farmers weren't really affected by restrictions. Obviously there was no rain, so the ones that were just dependent on the rain, they did lose some of their crops. But they weren't dramatically affected, and as I said, industry was protected. Now if you shift to 1995, by contrast, the drought in the north of England, the whole sector had changed. In line with the politics of the time, water had shifted from being seen as a public service with water authorities, and it had become a private industry, tightly regulated, but a private industry with companies. So in that 1995 drought in Yorkshire, what happened then was that manufacturing industry was sacrificed. There was a very memorable interview on the television with the head of Yorkshire Water, the water company in that area, and he advised Yorkshire-based companies to move south. And that made people pretty annoyed, those people who'd been laid off because of the restrictions on their industries operating. And his image, I have to say, wasn't helped by the fact that it was revealed in the press that he was having a bath at his mother's house, who lived somewhere in Humberside, I think. But it didn't help his reputation. Now, here's drought more recently. We're in drought. This is the creeping paralysis that, as I described it in my lecture title, that developed through 2010 to 2012 until water levels were so low across very large areas of England that there was a serious problem. And I want to illustrate the forecasting challenge that goes with this by this diagram here. This is the level of water in Rutland water in Midland England. And you can see it's 2010 and 2011 there. And you can see the amount of water in storage. I don't know what the units are there, I'm afraid. Percentages, I think. But the blue is the highest levels ever recorded in the reservoir, and the red is the lowest. And the long-term average is the grey line. But this is the line here that shows what actually happened. Now, if you're managing water, you're looking to see, well, when is this going to reach zero? Is it going to rain before this line reaches zero? And you don't know. Now, it used to be one of the rules of thumb that was used by people monitoring or managing reservoirs was that if that line, if you extended that line crudely with a ruler and it got to zero before October the 15th, you were going to be okay, because in historic times it had almost always rained before October the 15th. But that was the nature, the crude nature, the relatively crude nature of the forecasting. Now, most of you are probably running ahead of me now, and I hope you are, and thinking, well, what happens if we get climate change? What happens then? Okay, that's not going to make things better, is it? Well, that's the end of the drought too. It again ended with flooding. There we are, that's in Loughborough. Now, back in 2007, there was an analysis of those parts of Britain that were already stressed, underwater stress. And you can see there the red areas there, including London, that were already stressed. The balance between the available water and the demands on water were already very high. And all the models that we have of climate change suggest that's going to that situation is going to be exacerbated. Now, it's complicated because we have to go from models of things like how much carbon are we going to emit to what's going to happen globally in terms of water and temperatures, and then how does that play out locally, and how does it play out in a river basin, and then how does that match against how much water we need. Again, I'm not going to go through all of that, but we do know that temperatures are going up, particularly in some parts of the planet already. The blue areas there are areas where it's going to be a bit colder, perhaps, in the models, but most of the areas it's going to be hotter, including Britain. We can see that actually in the temperature record already, and some of you will probably have seen this in the media. This last year was the hottest on record, I believe. I don't know the length of time that the record has been is being quoted when that is said, but from the 1780s onwards, this is a very obvious time when there's been a lot of hot years. So what we have to do is to recognise, I think, that we've moved into what some other commentators have called an Anthropocene Age. drought is more likely to be associated with areas of the world where both the rainfall goes down, as we show in this diagram here, precipitation is less than you might expect, and the temperature is going up. Now these are again models. These are for different rivers in the world, and it's this area here. If we're talking about rivers or areas in this area here, hotter and drier, that's when we need to worry. And quite large areas of the world are in fact in that situation. We think that meteorological droughts will increase, and in England, if you want to translate this uncertainty to England, it's estimated that there will be only half as much rainfall in the summer as there is now, and that will be a little bit offset by about 30% more rainfall in the winter. But what you can see here is we're becoming more like southern Spain, more like the drought that I showed you in southern Spain. There is work underway to explore that, but it's difficult. Now, we've got these areas then of global water stress. And our ability to deal with it, if we put this to a global scale, really depends on three things. Professor Jim Hall at Oxford describes them as the 3 I's: institutions, infrastructure, and information. In these areas where there are different colours on the map, how we, or our ability to respond at the moment, depends on things like what variability there is in the rainfall, what storage capacity per person there is in the water system, and then these dots here, the different coloured dots, are the relative wealth of the population. Now, clearly, if you live in, I can't remember where these different areas are, and I wrote them down so I'd remember, but if we were in California, we probably wouldn't need to worry because the Californian dots are still up here somewhere, even though their rainfall is very variable because they're wealthy. These colours below, these areas down here, right down in these the redder areas underneath, these are the African countries that really do need to worry. Okay, now I won't emphasise this, but we need a plan, don't we? As Joe Lewis points out, everybody has a plan until they've been hit. We in the West, we expect to turn on the tap and get drinkable water immediately in the kitchen sink, whatever the circumstances. So what about if that didn't happen? What about, although water's a basic human right, like air, what about in a privatised system as we have now, one region had almost no water left, as happened in Spain? What would we do? Well, this is what they do in California. They cover the surface of some of the reservoirs in floating black plastic balls to stop the rain evaporating. I don't think that's a very good plan myself. I think it's not likely to yield us long-term what we might call resilience. I'm not going to go into the sociology of resilience because we don't have time, but what we're trying to do is we're trying to absorb the shocks. We want society to be resilient in the face of shocks. So if I were in California, I think resilience is probably not really being dealt with appropriately here. We should perhaps be trying to persuade people, but this is heretical, to use less water to cut that 2,500 litres a day down a bit. Okay, we need to cover with our resilience a whole lot of different areas, including navigation and fisheries and farming and so on, and industry. It takes about 15 litres of water to make a half a litre bottle of Coca-Cola. That's why businesses are terrified by this. We need to protect ecosystems and so on. Now, again, I'm not going to go through all the options for how we might adapt to this situation. There are lots. It don't include, in Britain, at the moment, as far as I know, black plastic balls, but they do include moving water around in large quantities from one part of the country to another, with all the ecological problems that implies. And other things, we could reduce the pressure in the pipes, we could try and stop leakages That's not being done terribly effectively at the moment, at least in my opinion, because the targets are actually based on something called economic leakage rather than the actual volume of water. We could use desalination, but it's very expensive, and so on. Now, as I say, I'm not going to go through all of this, but the couple of questions I want to leave you with. One is, how much would a litre of, let's say a cubic metre of water in Wales cost a Londoner if Wales had the water and London didn't? In a privatised system where we've got two companies bidding against one another, my money would be on the Welsh, actually, being in the dominant position in that discussion. Water, as we say, is not now a public service, essentially. It's a private commodity. And we've seen that commercial philosophy in action. It's a very complex situation as well. Sorry, there's the long-distance things that are being planned for this country. Some built, indeed, already. So we have a plan. Very complicated. We have emergency plans too. In an emergency, each water company has a plan and it will tell the local council about that plan. Well, that's good, isn't it? I mean, they will tell them what the plan is. It might be, we're cutting off your water, I suppose, but at least they would be told. And the Environment Agency would monitor what was going on, because that is the situation that we have at the moment. It will make sure, it says here, that water companies have assessed the risk and are taking the right steps to avoid emergency actions. Well, possibly, there's an emergency. Don't you remember that guy? Yeah, Michael Fish. Remember this guy? Dennis Howells, the drought minister, who caused caused flooding everywhere he went. Okay, so in this situation, would it be fine today for Thames Water's chief executive to say to companies in London, move north, which is what happened in Yorkshire, while he goes to take his shower in the Midlands? Okay, now probably not, I would say. If it got really bad, there would be government involvement, something called COBRA, which you've probably heard. It's the Cabinet Office briefing room. It's been activated in the flooding scenarios recently, actually. But we're in a situation where companies are actually taking the decision on what happens. The Environment Agency is just informing the government what is happening with maps like that of drought. Now, my last question to you, which I want to leave you with, we've explored droughts, we've seen what happens, we've heard some stories, we've seen what can happen as a result of a drought. And I'm quite interested in myself in what the scientist's role in all of this is. As a scientist, I'm interested in drought, and this is an analysis by Roger Pielka of scientists' roles, and he describes 4 roles here: pure scientist, science arbiter, issue advocate, and honest broker. The wording suggests, we want to be an honest broker. But so we can understand the differences, I explained it in terms of how we might choose a restaurant, or advise somebody if they wanted to choose a restaurant. So a pure scientist says, well, here's a set of guidance on diet, sort it out yourself. An arbiter says, oh, well, you can ask me the questions, and you ask me the right questions and I'll tell you the answers. This one, issue advocate, he says, oh, well, you really like Italian, go there. That's what I'm telling you. And here we have the honest broker. Here's the information. Here's the analysis in a droughts context. Here's the analysis of the impacts of drought on water supplies. So I'm telling you everything here, offering you a smorgasbord of information here, so you can choose the information. You don't have to guess what information you want. I'm giving it to you. Now, the point about this is that we can aspire to this. We can aspire to be honest brokers. But my final question to you really is, who are we actually as scientists, if scientists like me and other people, who are we actually telling? Because we might think we're telling these guys. Remember these guys? The ministers. But actually we're not now, because the ministers don't have the role they used to have in managing water in droughts. So actually the question I will leave you with is, who actually is in charge in a drought? Thank you.